Hello, welcome to today's lesson. Today we're going to be talking about rational functions. The two important features of rational functions are, first we have to find asymptotes, both vertical and horizontal, and then find our intercepts, both the x and the y intercept. That's it! Hope you enjoyed today's lesson. Let's now talk about graphing rational functions. What is a rational function? Well, remember what a rational number is. Any number of the form a over b, where both a and b are elements of the integers and b doesn't equal 0. That's what a rational number is. Well, let's extend that to functions. What is a rational function? If I have x maps onto, or f of x is equal to ax plus b over cx plus d. Well, in a rational number, I have to say the denominator cannot equal 0. b cannot equal 0. It's the same thing with the rational function. My denominator, cx plus d, cannot equal 0. If we're going to graph a rational function, one of the first things we know is we want to find our vertical asymptotes. Intercepts and asymptotes are so important with graphing rational function. Well, here is what a vertical asymptote looks like. With the vertical asymptotes, you think of them as tougher. Our graph cannot pass through the vertical asymptote. Where is that going to be? Well, wherever our denominator is equal to 0, we'll have a restriction. So in this case, our denominator is 2x plus 4. So 2x plus 4 cannot equal 0, or if it equals 0, that will give us our asymptote. So 2x equals negative 4, so x is equal to negative 2. There is a vertical line at x equals negative 2. Our graph will not pass through that line. That's our vertical asymptote. Well, how about horizontal asymptotes? We're going to have three different situations there. If I say bottom heavy, I could have something like 2x over 3x squared plus 1. I'm looking at the degree here. This is x to the first and x squared. Well, it's bottom heavy, and if that's the case, we know that y equals 0 is our horizontal asymptote. That's the x-axis. If we're top heavy, for example, if I have 3x squared over 2x plus 1 as a rational function, I can see that the degree in the numerator is greater than the degree in the denominator. I'll call that top heavy, and from there we can conclude that there are no horizontal asymptotes. If we have an equal degree, for example in this function we had 3x plus 1 over 2x plus 4. Our degree here was 1 and 1 for our exponents on our variable. If that's the case, we look to the coefficients, 3 over 2. In this case, y equals 3 over 2 would be our horizontal asymptote. Now, a lot of times you see close to the x and y axis, the origin there, our actual graph of our rational function will pass through a horizontal asymptote. A horizontal asymptote will not be passed, however, when x approaches plus or minus infinity. In other words, when we get away from the center of the graph, the xy where they meet at the origin, when they get away from there, as x gets bigger and bigger and bigger, our graph will go towards these values, these y values. But in the middle of our graph, you can think of it like that, they can cross over. Let's continue on now talking about rational functions. As I mentioned before, the two most important features of a graph of rational functions are the intercepts and the asymptotes. We talked in our last session about how to find the asymptotes, the vertical asymptotes and the horizontal asymptotes. The other part that's important with rational functions is the intercept. Well, how do we find the x-intercepts? Remember, if I'm having an xy axis, that's where my graph crosses the x-axis. If I have x versus y, I want to find those intercepts. How do I do that? Well, I just have to find x-intercepts, I put a 0 in for y. So if this is our function, f of x equals 3x plus 1 divided by 2x plus 4, I have to put a 0 in for y. So if 0 equals 3x plus 1 divided by 2x plus 4, I can multiply both sides by 2x plus 4 times 2x plus 4, and of course that will leave me with 0 equals 3x plus 1. Because this will cancel here, and that times 0 is 0. So now all I have to do is solve for x, minus 1 from both sides, divide by 3, and I get x is equal to negative 1/3. That would be the point. X is negative 1/3, y is equal to 0, because we substituted a 0 for y. How do I find y-intercepts? Well, given that same function, f of x is equal to 3x plus 1 divided by 2x plus 4. To find y-intercepts, substitute 0 for x. To find y-intercepts, we substitute a 0 for x. So in other words, we're finding f of 0. That would be 3 times 0 plus 1 divided by 2 times 0 plus 4, which would give us 1/4. If we put a 0 in for x, we're talking about 0, 1/4. That is our y-intercept. That will be up here. We just found another point on this graph. Again, to find x-intercepts, plug a 0 in for y. To find y-intercepts, plug a 0 in for x. In other words, find f of 0.